Hi everyone, this video goes along with the Chapter 3 lab, which is all about the law of large numbers. The law of large numbers basically says that whenever a probability experiment is repeated over and over and over and over again, so we're talking thousands of trials, then the empirical probability of an event will eventually approach the theoretical probability of the event. So we're going to simulate this using the flipping of a coin. Right, so kind of in basic terms here, if you think about it, if you take a penny and you flip it, say, 10 times in a row, it's probably not likely that exactly 5 of those trials is going to come up heads and exactly 5 of those trials is going to come up tails. But if you were to flip that coin and record all of the outcomes, say, 2,000 times, the number of times that it comes up heads out of 2,000 trials, or the number of times it comes up tails out of 2,000 trials, will be fairly close. That proportion of heads and tails will actually be very close to about 50-50. So what we're doing in this lab is, again, kind of simulating that empirical probability limiting, or the limit process of an empirical probability being very close to the classical probability. Now this is a lab that is typically done, in person in class, so it's kind of hard to do it online. Essentially, you're going to have to find somebody in your life to do this coin tossing experiment with you. So for instance, let's say I have, my cousin Sally sitting here with me, and she is going to help me with this lab. I would put my name under coin tosser number 1, and I would put Sally's name under coin tosser number 2. And then essentially you just take turns. While I am tossing the coin, Sally is tallying up what's coming up heads and what's coming up tails. You're going to do this for each coin tosser 50 times. So after you're both done tossing the coin and the other person's tallying, once you're both done with your turn, you should have a total of 100 tosses, right? So let's say that I toss the coin 50 times, and exactly 23 came up as heads and 27 came up as tails. So that means my relative frequency is going to be 23 out of 50 for heads and 27 out of 50 for tails. And actually do the division here. What is that as a proportion, right? For fractions, we take the numerator and divide it by the denominator. So read the fraction downward to do the division. 23 divided by 50 as a proportion is 0.46. So that means that my proportion for tails must be 0.54. Okay. Now, the sum of your relative frequencies should be 1. So 23 out of 50 plus 27 out of 50 is 50 out of 50. So the sum of the frequencies divided by 50 should be 1. Empirical probability, that sum should also be 1. So you're essentially going to fill out this chart for both coin tossers. So I would then tally while my partner was flipping the coin. So maybe my partner came up with 24 heads and 26 tails. I would fill in her relative frequencies with my fractions. Whoopsies, not out of 26. 26 out of 50. And then I would put in those empirical probabilities. So 24 divided by 50 is 0.48, and 26 divided by 50 is 0.52. And the sums come up as 1. So those are what I'm calling the individual totals. So each coin tosser has a frequency out of a total of 50 tosses. Then you come down here, and the third chart down is the combined partner totals. So between the two of us, we had 47 heads and 53 tails. So a total of 100 tosses here between the two of us. So that means my relative frequencies are 47 out of 100 and 53 out of 100, which makes our decimals super easy because this is 0.47 and 0.53. And that's basically all you have to do for this lab. I can't really do the class totals until everybody does the lab. So actually kind of stay tuned, and we'll return back to this activity once everybody has submitted their totals, and we'll do a little bit of comparison. So just in the short run of 100 tosses, we can see that the proportions are not exactly half and half, right? It's close. It's 0.47 and 0.53. But the more times that we repeat this probability experiment over and over and over, the closer those ratios are actually going to get to 0.5 and 0.5. So once we get everybody's results and we can kind of tally the total number of heads and tails for the entire class, we're going to make some comparisons between our individual ratios here and the ratios that come up, the empirical probabilities for the class total. Okay, so stay tuned for that, and just we'll go through this as results come in. Thanks, guys.